Hi, I'm Bailey with MyMathExperts, and today I'm going to teach you how to simplify the following expression, 3x minus 1 over x plus 2 minus x minus 2 over x minus 1. Now, I chose this problem to go over because I see students get this type of question wrong a lot. They know that in order to do fraction subtraction, you need to get a common denominator, but the thing that I see students struggle with is actually how to get that common denominator when you have variable expressions as the denominator. So something I see a lot is students see that there's a plus 2 here and a minus 1 here, and they just say, oh, so then I should just multiply this side by 2 over 2 and this side by like negative 1 over negative 1, and then I'll get a common denominator. The problem is, let's see what happens when we play that out. On our left-hand side, our denominator is going to be negative x minus 2, and on the right-hand side, our denominator is going to be 2x minus 2. If all we're doing here is just distributing these, we don't even care about the numerators right now. So we can see these are not the same denominator. So if you approach this using this strategy, you're actually not getting a common denominator, even though it feels like kind of it should work. So let's talk about the correct way to approach this. So whenever I personally see things being added or subtracted in numerators and denominators and fractions, I like to put them in parentheses just to indicate really clearly to myself that the x plus 2, for example, that's together. So you can't break those apart. You can't just say, oh, I'm going to do something with the 2 apart from the x. Those are together. They're in parentheses. So actually, in order to get a common denominator here, we're going to have to multiply the left term here by the entire thing, x minus 1. And we're going to have to multiply the right-hand side by the entire thing, x plus 2. And let's see what happens when we do that. So on the left term here, we're going to have, I'll just leave it actually right now as x minus 1 times x plus 2. And on the right-hand side, we can see we're also going to get the same thing, x minus 1 times x plus 2. So now these actually both are the same denominator. So that is good. That means that our first step here is complete. I'm just going to rewrite what our numerators would have to look like then too. So now that these are the same denominator, we can actually put them in the same fraction. So we can say minus x minus 2x plus 2 over our common denominator here, now that it's the same. And now all we have to do is just simplify. So kind of a pain, but not the difficult part. We're past the difficult part. Now it's just simplifying. So now we just have to distribute. This is going to be 3x squared minus x minus 3x plus 1. And then something to be really super careful about here, I'm going to leave this minus here for a second. And then when I expand all this stuff out, I'm going to put it in parentheses because we're going to eventually have to distribute that negative into everything. But I think that's kind of confusing to do right now. So I'm going to save it for later. And I'm just going to leave that minus there for now. And I'm just going to work these guys out and just make sure to put that in parentheses. So that's going to be x squared. It's going to be plus 2x. That's going to be minus 2x. And that's going to be minus 4. Okay, and we're still all over our big denominator here. Give us a little bit more space. And then let's distribute this minus sign now to everything here. So we'll rewrite our work here. That's going to be a minus x squared minus 2x plus 4 over our big thing here. Great, and now we can combine like terms since everything's out in the open up on our numerator. So we have a 3x squared minus x squared. Always remember to look in front of the number to make sure if it's positive or negative. So that is going to be simplified to 2x squared. We also have, for our linear x terms, we have minus x, minus 3x, minus 2x plus 2x. Well, these guys are going to cancel out. Minus 2x plus 2x, those just cancel. So we're just left with this minus 4x here from the front. And then for our constant terms, non-variable terms, we have a plus 1, plus 4. That's going to simplify to a plus 5. And then we have our denominator, which, let me look at our answer choices here. I'm just going to kind of move this. Let me do some magic here so that we can compare what we have now to our answer choices. Move this guy. Okay. So it looks like our answer choices are expanded out in the denominator. So let's just expand the denominator out real quick to make sure we're going to get the same thing here. So that's going to be x squared plus 2x minus 1x minus 2. And then if we combine these like terms here, plus 2 minus 1, that's going to simplify to a plus 1. So our denominator is going to be x squared plus x minus 2. With our same numerator, we didn't do anything to that. So let's see if that is one of our answer choices, and it is. Looks like that is answer choice D. One other thing I want to mention right at the end here is some people will try to start canceling things at this point because they'll start saying like, oh, I have an x squared here and I have an x squared here. Those are going to cancel. And I have an x here and an x here and those are going to cancel. Remember, if you have things that are being added or subtracted together in numerators and denominators, those things are all in parentheses. They're all together. So in order to cancel something out, you would need to be able to factor it out of like every term in the numerator using like greatest common factor and factor it out in the denominator as well in order to be able to cancel them. And we can see there's no greatest common factor for 2x squared, 4x, and 5. So we can't cancel anything there. And there's nothing with the x squared plus x minus 2 either. So since there's nothing we can factor, we can't cancel anything. You could also use the other kinds of factoring, like factoring trinomials and stuff to cancel too. But yeah, that is how you solve this problem. Thanks for watching. I hope that helped.